I know you probably can't wait to start programming, but interfaces are important, and that's why you're here. The good thing is, you already know what an interface is. You just haven't been calling it by that name. Let me show you what I mean. In this channel, we like to keep things relevant and simple. If you've ever played any games or ever used a TV, you are already halfway to understanding interfaces. Let's think about a game console first, like an Xbox or a PlayStation console. You turn it on and you pick up the controller. You've got the trigger buttons in the back, a couple of joysticks, a D-pad, some key buttons, and maybe a menu start button. The controller is our interface. Is it really that simple? Yes, but there's more. Let's keep exploring so you know how it works in programming. Another way to think about that controller is like it's a contract. Yes, I know, it's not a contract on paper, but that word describes its role for the game console. It's a set of rules that everyone agrees to follow. The console maker, like Sony or Nintendo, designs and decides what buttons their controller will have, and they're stuck with that for the rest of the console's lifetime. And the game developers, like Ubisoft or Gearbox, they accept this layout when they choose to make a game for the platform, and they already know what buttons they have access to when creating the games. The key thing is that because the controller layout is decided and set in advance, anybody interacting with the console, from devs to the players, they all know how to communicate with the console using this controller. The game developer doesn't have to know how the controller's electronics send the signal when we press the A button. They just trust that the users will have the ability to press that button when they play. So now you know the interface defines what something can do and not how it does it. For example, an interface for a game controller might specify that you must have a way to move the left joystick, and you must have a way to press 4 key buttons. Then, a developer can make use of this interface to interact with the controller's input. When the joystick is facing down, it can be used to crouch in one game and to move the player in another game. The action will depend on how the game implements the use of the controller. And that gets us to the other keyword when using interfaces: implementation. Alright, now we're ready to take this one step further with accessories. Let's talk about headsets in particular. We can write an interface called console headset, so we can specify to our console the features it can expect to interact with from headsets. Let's see. The absolute must-have functions for any headset to work with our console. Well, it needs to play game audio, and it needs to accept microphone input for chat. So, our console headset interface will be a contract that says any class that wants to be considered a console headset must provide a way to play audio and a way to get microphone input. Here's what it might look like in code. If you've never seen an interface before, it may look a little strange. We're not really writing any code that does anything. We are simply defining a structure. So here's what you should look out for. You usually write an interface with an abstract class or an interface. It just depends on the language you're using. In that interface, you write empty methods or variables that are expected to be implemented. Now, here's the fun part. Let's imagine Sony, Turtle Beach, and SteelSeries all made headsets for your console. I hope this already looks simple enough, but let me explain further. The headset variable can be any instance of the console headset interface, and we set up a loop condition that goes something like, while our game is playing audio, then play audio from the headset. So why do we even need to use interfaces for this code at all? I could just have a way to play audio and run that when I need it. But consider this, you don't know how many headsets will be made for your console and how they might play audio differently. They might use different audio processing when playing audio, for example. In that case, writing your code with an interface makes it so that the code interacts with the expectation of a console headset rather than the specific headset directly. And this is a really flexible and powerful tool when used correctly. So, big whoop. I just taught you how to write a contract that your code has to follow, but we are programmers, not lawyers, so why do we even need these contracts if we're making something that doesn't need to support a ton of options through an interface? And that's the landmine question that explains why we should use interfaces. We use interfaces for many reasons, but I'm going to tell you some of the most important ones. When the logic in your program makes use of the interface methods, it makes it easy to create new implementations without having to rewrite your logic. And nowadays, With code completion in IDEs, it's really easy to make your classes implement an interface without having to remember to write the entire specification. Just a few clicks and you're ready to go. Another reason we use interfaces is to achieve something called abstraction. Now, abstraction may sound like it's a complicated thing, but it's really all about handling complexities. When you have a piece of code that's integral to the program, but also really big and complex, you take parts of it that can be generalized and you abstract those parts from the main code so that they can become more flexible and easier to use. If you're not familiar with inheritance in programming, it's when you write out in your program that one object inherits everything from another object. This works most of the time. You can make a car inherit from a vehicle, but you're limited to one inheritance per class. So what if you wanted to design this car to be able to use an engine that's really complex, a chassis that's really complex, and maybe a brake design that's really complex? You can't bring in all of those well-designed pieces into the car class because of the single inheritance limit. But with interfaces, you can bring all of that functionality into the car, and whenever you need to update any of those pieces, you can do it separately from the car, which should be helpful for keeping your code clean and free of bugs. So now you know, interfaces were kinda like game controllers this whole time. It should be really easy to start writing your first interface, because you don't even need that code to perform any actions. Just pay attention to the syntax. Make a plan on what interface you want to write and how other classes will make use of it. And then go out there and write these interfaces.